The audio, I don't know what it is. So, yes, I am muted again. I think I'm just gonna quit and give up doing Tuesday sessions. This I can't apparently can't remember to double check the mute, which just comes on this laptop for some strange reason. So, yeah, I appreciate everybody for coming, um, and watch me move my lips for a few minutes before it catches up. And I know there's a delay, so yeah, it's probably like a minute or two delay. So I still see a ton of messages, and it kicks in. It always makes me feel like the biggest idiot as well. And you think I would learn by now to make sure that it's it's working. So, but I do appreciate everybody for coming. And what I was saying while I was on mute was talking about the idea is that um, today we're going to talk about using Wireshark in OT environment. So it's a very popular and common tool you see everywhere in IT, and we also see it a lot in OT as well. So, um, but yeah, and I don't know what kindly accept me in Teams means she and not sure. So, but I do appreciate everybody for coming and for being here. So, um, so what I was talking about, sorry again, I try to shrug off the feeling like the biggest idiot in the world for like the 10th time. You would think I would eventually realize. Um, but with using Wireshark for not only troubleshooting perspective, but also using it from a security perspective as well. And you might go into an OT environment. It doesn't matter how large. Right? I've been in some of the largest ones in the world. I've been in some of the smallest ones in the world, and everything in between. And there's always, something that you can take a look at, whether from a security or from a troubleshooting perspective, using Wireshark. And the great thing about Wireshark is it's free, right? We don't have to pay for it. It's an amazing tool that has an amazing community that's built up around it. People have built these parsers into Wireshark so that it can actually dissect, right, different um, protocols, including OT protocols, and ideally tell us in, they would say, plain English. It's not plain English, but at least in easier to understand terms that we can see of what's going on. And typically, you still have to have a basic understanding of how protocols work. So to get understand, let's say if you're seeing Modbus for the first time, right? Modbus is the most commonly used protocol we see in OT or ICS environments. If it's the first time you're seeing it, it probably makes sense to take 5, 10, 50, 30 minutes to go through a brief kind of high level overview of what Modbus is and how it operates. So that way, when you are looking at it through Wireshark, you have a better understanding of what you're actually looking at. It's also very similar to when you take somebody from the IT or IT cybersecurity world and put them in an OT SOC. Yeah, and you start looking at all these different alerts and these events and traffic, and it, everything could potentially look like an attack or that it's suspicious or malicious. And it's not the case. It's just right. It's at that point, it's just very new to you, and you need to take the time to understand what's actually happening or what's going on, right? And so, again, I just wanted to spend some time looking at Wireshark, and we'll look through some examples, and we'll talk. We'll actually look at a couple of. There's also some great GitHub repositories that are out there that you can use to look at different packet captures. Ampix. Forget the full name. I think it's just Ampix itself. So it's the OT cybersecurity company that they focus on primarily power. Um, the power sector, and that's run by Patrick Miller. And I think he and Dan Ritchie had come up with a um, I wouldn't say if it's an online contest per se, but it was more of a challenge that you could go through, and they had packet captures, I think, from three different environments, right, that focused on different OT protocols. And so we'll also take a quick peek at that as we're wrapping up, and that can be something that you can work on as well if you want to take this further and find it a little bit more interesting. So, but yeah, that's the idea. I'm going to actually copy a link into the chat. Hopefully, everyone will get this. Sometimes, depending on your privacy settings, you might or you might not. But I'm going to drop it here. I'll actually probably repost it, so you might see it once or twice extra, depending on if you're on YouTube or you're on LinkedIn. But you know, laptop likes to come unplugged. All right. Now, what these actually are, and again, I'm going to repost these. So hopefully, depending on which channel you're coming from, oh, it looks like in LinkedIn, you might not actually get these through Restream. Let me see if I can log in to the session there and add them. But I'm going to try the. I'm going to drop it, and it should appear in the comments. Okay. So you actually should see it in LinkedIn. It's kind of a pain to have to do that. But as long as everybody gets it, that's all that matters. So what that actually is okay. Uh, it's some packet captures that I had put together for my intro to OT pen testing course. So, and we'll look at some others. Again, there's some GitHub repositories out there that I've shared before, and we'll look at that have some great different packet captures for learning OT, and then actually looking at again the Ampex challenge that focuses on those three different protocols. If I remember, DMP3, which is used in electric, that's one. I think Modbus was the other. I forget the third, but we'll look at those before. So if you're looking for the recorded sessions, and thanks for asking, Prasan, the best place to find them is actually over on my YouTube channel. So if you're watching through LinkedIn, LinkedIn doesn't really necessarily do a good job of kind of making them available, right? Like as in an archive. So if you go to LinkedIn and if you just search for Mike Holcomb, you'll see my channel. The channel for right now is named Utilsec, which is the name of my company. So UTILSEC. But Mike Holcomb takes you there. You see my lovely face in blue. And then when you're there, you can go to live, and so then this will actually list all of the different live sessions that I've actually done previously. And you can see a little bit of how they've evolved over time. And beginning to update some episodes. Numbers 11, see, 12, 13. So this is number 14 that we've done. But yeah, that's the best place to find them. You can find them on LinkedIn if you scroll through the post, but I don't think that's really necessarily right. Super easy to do necessarily. So, but yeah, just definitely check out YouTube and click on live under Mike Holcomb, and you'll find all the previous recordings there. So yeah, hopefully that helps answer that question. So, but thanks for coming, Victor. I appreciate it. So glad you made it. So. Um, but yeah, so let's look at Wireshark. So for those of you that have the link, and have access to that Google Drive location. Let me go ahead and share that out. So if you're just watching, you'll actually see what you would actually be looking at, right? And so you can see there's 1, 2, 3, 4, 5, 6, 7 packet captures. Right, so there's most of them are the kind of the older original version, the PCAPs. You can see a couple newer ones as well. The first ones, and these are the ones that we're going to start looking at. We're just going to look at pen test 001 first, just to get started, right? Just to get the idea of what we're looking at, kind of get the look and feel of Wireshark. Drop in the comments and let us know, are you new to Wireshark? Have you been using it for forever and a day? Or maybe somewhere in between? Have you used it in IT? Have you used it in OT? Just curious to see kind of where everybody is at using Wireshark, right? But while I do that, I'm going to go ahead and open that up in Wireshark. So let me switch over to Wireshark, and hopefully this is going to be large enough for ideally everybody to see in let me in the session. Yeah, I think that's actually pretty decent. So hopefully that works for everybody. But and so again, we've opened up the first packet capture in Wireshark. Yeah, I'm just expanding it and I'm making sure that it's readable. Okay, good. I think hopefully that's still very much doable for everybody. And so this is again the first packet capture I created for the pen test course. So it was again, it's meant to just get us started and getting us thinking. So if you haven't used Wireshark before, especially, or if you haven't used it in an OT environment, right? It's really supposed to just help us kind of get up and running with the basics, right? With the basic fundamentals. So okay, good. So yeah, it looks like Omar's used it in IT, but not OT. Jokes with noobs or nobes is new. Russ, probably like me, has been using it forever, but and just for packet filtering, all those wonderful fun things. So yeah, this is not supposed to be like a really complicated example. Again, just to get us started. So there's a couple things that we see, right? And let's go over, kind of look at the columns, right? First, just as a quick introduction, right? So in the first column, you can see the packet number. So we can actually see the first packet captured, the second packet, right? So on and so forth. And then you can use that to understand not only, okay, how many packets are in the capture, and then you can also see that in the lower right hand side of the screen, right? But also, if you're sharing information with others, right, you can say, oh, look at, packet number 5238, right? This is where the attack starts, something along that nature, right? So it's nice to have the packet numbers that are listed. You can see at what time that they were actually recorded. Now you can actually put the real time. In this case, you're actually seeing relative time. So you're just seeing, from the start of the capture, right? At what time from the very start was that packet recorded, right? From when we clicked start, how long had passed until we recorded that packet, right? But you can change it to show the actual date and time if you need to. And that's great, especially when you think of things like forensics, right? But we can see, some of the more important information usually is the IP addresses, right, that are communicating. So we see the source IP address, in this case, 192.168.1.15, right, if we're looking at packet number one. And then the destination is 192.168.1.186. So we have the IP addresses that they're communicating with, which is definitely extremely important, right? That's going to be the assets or the computers that are talking. Then we see the protocol that they're talking in. In this case, we could see it's TCP. And then we can see the length of the packet, which doesn't necessarily come into any of the conversations we're going to have today. So there are definitely some interesting use cases, especially from a network security monitoring and incident detection case. And then In the rest, you see info, right? Is really a big one. But if we're looking at that first packet, we see 50,201 and then an arrow pointing to the right and then to 502. What we're actually seeing there are the ports, and in this case, the TCP ports that are being used to send from the source computer, right, at 192.168.1.15 to the destination computer at 192.168.1.186. And so, right, the source port is 5201 on dot 15, and the destination is port 502 on 1.186. Now, TCP 502 is most commonly used for what? I know there's a slight delay, so while I wait for some folks to answer what TCP port 502 is used for, I'll actually go and see if there's actually any other questions that there are. Julie Caesar says, "Can we zoom in on the Wireshark?" I don't think I can actually probably zoom in on it anymore, other than what I can do is stop showing my lovely face and but it doesn't. Let's do this. There we go. Hopefully that makes it better, especially if you're on mobile. So, um, and then let's see. Um, What is this? So Primal Flex asks, "Hey Mike, are you considering making something on the considerations needed to build an OT program at an organization from scratch?" Actually, yes, I am. I haven't actually announced it yet. So, and no, I didn't pay anybody to ask ask this question. I'm actually going to launch essentially a workshop or mastermind or group in April. Right? And the plan is to have that run 10 weeks. And it's going to be a small group meant for people that, at least at first, are owners or operators or working in OT environments. It could be consultants, but it's going to be people that are in OT or ICS environments and understanding, over those 10 weeks, right, building an OT cybersecurity program. And whether you have, maybe an existing program today and you just want to know, okay, how do I take this thing to the next level? Or starting from scratch. I know, especially I talk with a lot of folks, especially that come from an IT cybersecurity background, that all of a sudden they're given responsibility over the OT network and don't know where to start, right? Or, it's like, what do I do? So it's really designed for people that work in OT or ICS environments and really want to understand how to build a program. I built some of these programs for some of the largest industrial control environments in the world. And again, and some smaller ones and everything in between. So yeah, this is going to start in April, but keep an eye out. I'll be announcing some information probably pretty soon, but also trying to make sure I tailor it right to everyone, in the community. So I'll also be sending out a questionnaire, especially through my newsletter and posting on LinkedIn, to ask a little bit more questions around that. So, but I appreciate you for asking. Yeah, best way, again, I haven't announced anything yet. You can always ping me on LinkedIn, or keep an eye out on the newsletter and then my LinkedIn profile. The newsletter is probably the easiest thing because LinkedIn doesn't do a very good job of, showing you, content from the people that you're connected with or you follow, unfortunately. So, but that's just what it, yeah, kind of way it is. So the newsletter is best. And if you're not signed up for the newsletter, definitely go to LinkedIn and you can find the link um, under under my profile. That's usually the best way to do it. All right. So yeah, so I see a lot of folks pinging in and saying, yeah, TCP 502 is being used for Modbus, right? Yeah. So Justin and Omar and Mohammed and Farron and yeah, I really, appreciate you jumping in. And yeah, we're using for Modbus. Remember, Modbus is the most commonly used protocol that we see in OT or ICS environments. Of course, there's a couple of things we look at it as well from a cybersecurity perspective. Now, one of the things that a lot of people will immediately jump on and I get this, especially coming from an IT cybersecurity background, is that if we open up this packet capture, we can immediately read all of the traffic, and we didn't have to take any different, like, particular steps to do that, which means that Modbus is what? If I can just look at the traffic on the wire, right? Is it encrypted or is it unencrypted? When we actually look at it, and this is one of those unique things when you look at, or start to compare IT versus OT, right? When you look at an IT network, the vast majority of network traffic is encrypted. Remember, the last organization I had worked full time for was, it was still about, I think, 25, 30,000 computer users at that time when I left. When I started, it was like 80,000, and then by the time I had left, when they had still had 25, 30,000 users, that it was like 98% of the network traffic was, yeah, encrypted, right? Which means if you're doing things like network security monitoring, it can be challenging because you have to break that encryption to be able to read the traffic. In this case, Modbus is not actually, uh, Modbus is not actually encrypted traffic. Most OT protocols aren't. They're starting to see encrypted protocols these days, right? Because they're starting to add some basic security. But most OT protocols by themselves, yeah, they're unencrypted, they're clear text. So from a monitoring perspective, it makes it super easy. Now, if you come from an IT cybersecurity background like myself, you might freak out and say, oh my gosh, all the traffic is unencrypted and attackers in the environment that can steal all that information. And while it's not great if you have somebody in the network and they can read your traffic, but realistically, if they're already in your environment in a position where they can read the traffic, you probably already have a lot of other worse things that you need to worry about. So, um, can it help an attacker? Sure. Right, sure. Never say it won't, but again, if they're in a position where they can, watch your traffic and be in a position where it would help them, especially ultimately have an impact in your environment, again, you need to focus on worrying about other things besides the fact that you have unencrypted traffic in your network, right? So, but in this case, let's go back and look at the capture. Because we can see packet 1, 2, and 3. What we're actually seeing there is that's actually the TCP three-way handshake that's being used to establish communication between the systems at 192.168.1.15 and 1.186, right? It's allowing them to establish that two-way communication between those hosts, right? So they can send information in both directions. And then the rest of the traffic we can see is not TCP traffic, it's Modbus traffic. Or in this case, we say Modbus TCP traffic, right? It's a version of Modbus that runs over TCP. And there are multiple versions of Modbus that run over TCP, believe it or not, right? And so what we can actually see if we start looking at, let's say, that very first Modbus packet, right, is that okay? We can see again a source IP address, destination IP address, and now we're not worried about well looking at right source ports and destination ports. We already have that from the three-way handshake. What we do want to look at is the payload of that data, right? That was actually being sent. This is where Wireshark has these parsers that are built in. So it looks at the data, right? The ones and zeros that are being sent over the wire and then interprets them to show us, right? It parses or it dissects them, right? To, my dog wanted to say hello to everybody, apparently. That we could actually see right? What's actually happening? In this case, we can see that there is a read coil command issued from the one host to the second host. All right, and if you're not familiar with Modbus or as we have systems like programmable logic controllers. There are PLCs, which are the most common type of asset we have in an OT environment, right? They're designed to watch over the environment and what's happening by using data that it collects through sensors. And then it stores all of that sensor data in memory. And then it's programmed, right? It has logic that it runs through on a continual basis, like in a little loop, that it's always checking that data to see if it needs to make any changes out in the real world. And if it needs to make any changes out in the real world, it'll send a signal, maybe to turn on a piece of equipment or turn it off or make it go faster or make it go slower. And it does that by sending out signals. But again, ultimately, right, it has to bring in data from sensors and store it in memory in what they call coils and registers. Now, coils are where we store information as zeros and ones, right? It's binary data, just zeros and ones. And then in the registers, right, that's where we can store larger values. So anything between 0 and 65,535, right? So if we just need a quick binary value to determine whether something is on or something is off, that's usually what they're used for, then we use coils. If we need to store, let's say, a higher number, like for temperature or speed, right, velocity, right, um, pressure, right, those we would store in registers. So if I double click though, what's going to happen is it's going to bring up the Wireshark packet just for, right, that one packet that we're looking at. I was curious to see if this is actually shown on the screen or not. So I need to do see. Give me one sec. Here we go. Switch over. Right. So now we have the details of that one particular packet. Now, what I really like about this, and this is not necessarily a lecture on the OSI model, but if you're familiar with the 7 layers of the OSI model, right, the idea is that it shows us, right, how network communication between one or more hosts actually takes place. And the way Wireshark lays out is that you can see the very first line, and I can expand that to see all of this information and a lot of timing and when we got the packet, when we recorded that type of piece of information, right? This was frame number 4, the first Modbus packet. That's all information related to the physical layer, the first layer of the OSI model. Well, that's the first layer. Then the second layer, right, goes up to the second layer of the OSI model or the data link layer. Now, there's a couple of really cool or interesting things that happen here because remember, the data link layer is broken down into 2 sublayers. So you have the logical link control, and then you have the media access control layers. Logical link control is basically the software driver that allows the machine's NIC, right, the network interface card, the hardware, to talk with the operating system, right? So it allows us to convert, operating system or software speak into hardware speak there, where we can put zeros and ones out on the wire or the wireless, right? Whatever communication path that we're using to transmit and receive that data. But when we talk about, oh yeah, the media access control or the MAC layer, right? That's where we have the MAC address. So the MAC address that's associated with each network interface card, right? It's burned into each of those interfaces. And that the first half of that address is actually registered to a particular vendor. So in this case, there's a couple of interesting things that happen because not only do we see, like in this case, the destination, right, of the packet is going to a MAC address of 0011006789AB. But you can see that Wireshark went ahead and took the first half, right, the first 24 bits of the MAC address, and it did the lookup to say, hey, that MAC address is associated with Schneider Electric. So chances are that target IP address that we're communicating with, yeah, it's Schneider. So it's a common OEM manufacturer of OT equipment or assets. Awesome. Right. So it's a good piece of information to have, whether we're trying to build an asset register for our own company, or yeah, what if I'm an attacker or a pen tester in the environment? Right. It's useful information to have. And then we can also see the source. Now, if you look at the source, what's the source vendor and what would that imply, right? Is this going to be a typical OT or a typical IT asset? Go ahead and drop it in the chat, and I'll look for questions while everybody kind of thinks that over, right? So look at the source, right? And is that coming from a typical OT asset or a typical IT asset? See Mohammed adding some more information. I guess I don't see actually any questions. Other Saeed's asking, yeah, a lot of toys. Everybody asks, right? That's what we were talking about earlier. If you want to find the recordings, the best place to find them is to go to my YouTube channel at YouTube and search Mike Holcomb. That's usually the easiest thing. And then when you go to the YouTube channel, there's a section for live. If you just click live, it'll show you all of the recordings from the live sessions. So you'll find them there. So I think this is actually episode 14 officially of OT Cyber Tuesdays. So you'll see all the other previous ones there, and then any of the other live sessions that I had done uh, previously. So, and I think with YouTube, I have the option where I can go in and edit. So, like the first 3 minutes where I was talking on mute, I can delete that out. So I'll have to work on that today. So. But yeah, it's an typically an IT asset, right? When I see Dell, I think of, PCs, or I think of like my gaming laptop, it's essentially Dell, or it's Alienware, but right, it's they're owned by Dell, right? And so I started thinking, oh yeah, that's probably, in the OT world, it could be something like an engineering workstation, right? Or maybe a contractor laptop, or maybe it's an asset that an attacker has brought in, but it's something more like probably, yeah, an engineering workstation that's sitting there running Windows, sometimes Linux, but usually Windows. And if you're not familiar, an engineering workstation, yeah, it's just a Windows machine in the OT environment that we usually will use to connect to different assets like PLCs to be able to do things like upload new firmware, right? So for updating, to address a vulnerability potentially, right? Or a performance issue, right? Or if we want to go ahead and make programming changes, we're going to do that from an engineering workstation to that PLC. So we start to think, I'm like, okay, well, this destination is an asset that's from Schneider Electric, which is a big vendor of OEM equipment, right? They now own the Modicon series, which that was the original PLC that was made back in decades ago. And then I have this kind of more like IT asset, like a Dell machine, right? A PC or a laptop that's connecting to the Schneider Electric asset, right? So we have all these pieces of information, right, to start putting in the back of our mind to get an understanding of, okay, what are we actually looking at in the environment, right? So remember, these are all based off of the OSI layers, right? The first OSI layer, remember, that's the physical layer. Layer two that we were just looking at, right? That's the data link layer, right? Where we see things like the MAC addresses, which we can do a reverse lookup on that first half of the address to see, oh, here's the vendor. Now, the next layer is the network layer, right? And this is a lot of the information, or the important information we've already seen. This is the IP addressing information. So we already know the IP address it's coming from is 1.15 and it's going to 1.186, right? Great, awesome. So then the next layer we go to is we talk about the transport layer. And this is where, yeah, TCP happens. So this is where, well, and we already saw a lot of this information, the ports take place, right? This is where they're important. So which port are we coming from? Which port are we going to? Or yeah, that destination port is particularly important, right? Because that's usually, not always, but usually going to tell us, well, what protocol are we even talking about? What service? And we can start again, start putting those pieces of information together. So yeah, and Shiraz and Shiv talk about, yeah, it could be an engineering workstation, it could be some type of server, it could be a data historian. We have lots of different types of, assets in the OT network running Windows. Yeah, absolutely. But when you start thinking of, which ones would actually communicate with another system over Modbus, then usually, yeah, you would probably lean towards like an engineering workstation or an attacker being in the environment, right? Or maybe a contractor laptop. So, and then the rest is what we're really looking at ultimately is where we want to get to the actual application data, right? The data that's actually being transferred, right? The payload of the packet between those two hosts. Because remember, if we go back, we saw, oh, it was one host issuing a request trying to read data, right, from that target system. Now, this is a little ugly, but again, this is where Wireshark takes all those zeros and ones that are streamed and tries to bring it into a format where you can understand what's going on. In this case, it says, okay, we looked at that packet capture, right, in the payload data. It's Modbus traffic, right? And in this case, it's a the source system is issuing the Modbus command for read coils, right? So it says, hey, I want to read some of the information you have in memory, right? I'm going to read when I want to read the coils, not the registers. And then we have to tell it if I want to read the coils, I have to tell it which one or which ones I want it to read. Now, coils and registers, I hate this, but they're zero based. So it means the very first coil and the very first register are number zero, right? And then they increment from there. So in this case, we're telling it, okay, start at the very first coil, which is number zero. And then I'm going to tell it, give me the first two coils. So I'm not just asking for one value, I'm actually asking for two, which you can do. Hopefully that makes sense, right? So we're issuing that read. We're saying, okay, I'm going to read your coils. Show me the first two coils you have in memory. Right? Remember, the coils are where we store values in zeros and ones, right? Binary data, usually for to represent whether something is turned on or whether something is turned off. And in some environments, if you see a one, you might assume, okay, that means something's off, and you can change that to a zero and literally turn off a piece of equipment. Sometimes it's that easy. So believe it or not, not always, but a lot of times, right? So let's go back to Wireshark because that was that first Modbus packet that we're looking at. In fact, I'm just going to type in Modbus in the filter. So we're just going to take those top couple of TCP packets out of the way. And so you can see, all right, that was the first packet. Well, let's go ahead and open up the response because if we scroll over on the, well, if I get the right bar, right, we can still see here's the response. Well, what did that remote system respond to? Right. And at this point, you can probably start to tell, right, that destination computer or asset at 192.168.1.186, right? What type of asset is that? If it's storing data in coils and registers and it's made by Schneider Electric, what type of asset is that going to be? And go ahead and drop it in the chat, right? And again, there's a slight delay. I get that. So I'm just going to keep talking because this is where we see the response. Because remember, we sent or we issued the request to read two values, those coils. Remember, coils are zeros and ones, and we actually get the responses back. And it says, hey, the first coil, number zero, has a value of one. And the second coil, right, it, it also has a value of 1. So again, we might take it to mean that, yeah, these two individual coils represent maybe something that's being turned on. And so maybe the first coil represents that there's a pump that's turned on. And the second one represents that there's a motor running. But we have those. And yeah, yeah, more than likely, right, it's going to be a PLC, right, at this point. Yeah, so we have a PLC that we're talking to over Modbus, right? And that we're actually using that. Um, and I forgot I had to reshare the other little, um, sorry about that. If it'll let me, there it goes. Um, Screen, but where we can actually see, again, this is the response, and it's saying, okay, the first coil, bit 0, that the value is, yeah, 1. And then, oh, the second coil we're talking about, bit 1, right, is also a 1. Now, a lot of times, you usually just see a ton of zeros, right? So this is a little bit different. But again, maybe that first one indicates that a pump is turned on, and the second one, right, maybe indicates that there's like a valve open, right, or a motor running. But that's what we use, at least in part, Modbus for, is right to be able to communicate, and we can have remote assets like think like an HMI, right? It's going to query that PLC over Modbus for the information that it has in memory, because that's what it's going to display to the operator to show, hey, here's what's going on in the environment. Remember, the worst thing about Modbus, again, it's I don't necessarily care if it's encrypted or not. Right. Now, a client might care depending on how sensitive, right, the information in their environment about, the process that they have running. Right. We always use the classic example if I'm, at Coca-Cola, right? That if Coca-Cola doesn't want anybody to come in and steal their process or the recipe, right, on how they make Coke, they would lose billions of dollars. Right. So yes, of course they're worried about, making sure that information is encrypted. But if I'm making a generic baseball, right, or basketball, am I probably really worried about, the sensitivity or the confidentiality of my data in OT? Yeah, probably not. Right. But that's how the basics of Modbus work. But again, it's really cool that we can actually record that data, right? We can take it off the wire, and we can use a tool like Wireshark to actually then tell us, right, what it's actually saying, right? I think it's very, very cool. So let's see, David's asking, how can we implement encryption and authentication in Modbus? Yeah, so Modbus inherently, right, current versions, right, don't. So you either look at newer versions, and I think these are just starting to really be implemented, where you see encrypted versions of OT protocols being put into um, assets, or what you start to also see if encryption is a thing that people buy other pieces of hardware, right, to put in front of, right, your PLC and your other systems to do the encryption for you. So almost like having a kind of like a VPN, right, where you're establishing encryption, over traffic, going over like the internet, but now you're doing it internally, right? So if that was actually a concern, right? So there are different ways to do that by adding other systems, which, right, that gets really ugly really fast, right? Where you see most environments, again, they just don't not going to worry about it. And when you think about it, and the vast majority of environments still, they haven't nailed the basics of OT cybersecurity fundamentals. So honestly, right, encryption just doesn't even need to be on their list, at least not at this point. They need to grow and mature, right? Before they even get to a point where they need to be worrying, is their traffic encrypted or not? So, and it does make it easy from a network security monitoring perspective. So, but yeah, I would say the vast majority of OT environments don't worry about traffic that's encrypted. If they're worried about traffic that's encrypted, the nice thing is when you think about it, it's well, if somebody's logging into, let's say, a web interface for my SCADA manager interface to log in to make changes to the environment. Well, if you do that over HTTPS, that's already encrypted, right? So things like logging into web interfaces, you do that over HTTPS. So those are encrypted. So when you talk about, well, I don't want people to steal usernames and passwords. Yeah, use HTTPS when that's available, right? So use encrypted versions of traffic where you can, for sure. But things like when you look at communication between like an HMI and a PLC or an engineering workstation and a PLC, yeah, by default, those are going to be unencrypted. And that's what you're going to see again, the vast majority of the time. So, but Julia says, let's see, a PLC has an IP address and the status of physical components is stored in coils and registers. Yeah, exactly. Yeah, remember the job of the PLC is to monitor what's going on in the environment. So it's pulling in data from these sensors and it stores that information in memory. So if you look in the memory of that PLC at any time, you can get a status of what's going on in the environment. Now, you might not know what these zeros and ones and other numbers mean in the beginning, right? But you can, yeah, look at the um, that information right over Modbus because remember it's an unauthenticated protocol, so it allows you to connect without having to supply a username and password. So yeah. So yeah, some vendors are starting to evolve and how do we add now newer protocols like if we talk about things like OPCUA, right? They do have some basic, forms of encryption that are built in. I always like also talk about wireless heart, right? It's a OT protocol that goes. It's a wireless form of communication, right? There's a basic form of encryption there. So it's not like, we're completely wide open, but we're yeah, most protocol traffic on OT networks is unencrypted. But again, most environments they have other things to worry about first. And it's kind of like in IT, right? 20 years ago, it's like, am I really worried about the traffic, on my IT network being unencrypted? It's like, how about we put a firewall between IT and the internet first? Right? It's like, let's start with the basics. And then we'll get to a point where, oh, okay, yeah, we can worry about if all of our internal traffic is encrypted. Right? And that's kind of how it evolved. So, yeah. But anyways, so that gives you an idea, right, of Wireshark. Now, I did want to take a couple minutes and let me go back to looking at just the normal full Wireshark screen. Because if you're not familiar with Wireshark, the really cool thing about Wireshark, it comes with a lot of cool little built-in analysis tools for you. And so if you actually go up, and there's a couple of different menus up top, but if you go to statistics, right, there's a couple of different essentially reports that you can run that'll show you different pieces of information that can help you when you're doing analysis, right? So we can look at things like protocol hierarchy, what protocols are actually in this capture. And we can see, right, that, well, why don't we do this? Why don't we just stop screen sharing and just let me see if I can just share the entire. That's right. It freaks out when you do that. But you can see here where it shows you that, oh yeah, we have TCP traffic, we have IP version 4, and we have Modbus traffic. Right. So okay, that's really helpful, especially I think if you have a huge packet capture that you've just gotten, right? How would you even begin to know or understand what's in there? Right? Now, another important one is the endpoints, right? Let's go jump over there because with the endpoints, this is going to show us, or it's going to strip out things like MAC addresses, right? You can see the Ethernet tab. That's the MAC addresses, right? Here's so two MAC addresses. In this case, they're not doing the resolution for us, though. It's not telling us, hey, this is Schneider and this is Dell, which I wish it did, but it didn't. And then we can see, oh yeah, here's two IP addresses. Again, you might have a huge monster file that has hundreds or thousands of IP addresses. And then if it has IP version 6, and then we can see what ports are also be communicating, if it's TCP or then what if it's UDP. Again, this is a very simple packet capture. But the idea is that ultimately, right, the goal is we can use this information to get an understanding of what's going on in the environment. Again, and also think of how an attacker would use this as well. But ultimately, right here, it's where I get to understanding and being able to build in, okay, this is what the environment is starting to look like. I have this PLC over at 192.168.1.186. And I have this Windows machine, running on Dell equipment, right? That's an engineering workstation at 192.168.1.15. And we should know, right, whether that's an authorized asset in the environment or not. We better, right? And then, yeah, we can use that captured information, like the MAC addresses, to do the reverse lookup to determine, oh, yeah, that's a Schneider PLC versus, okay, that's a PLC or a laptop, that's a Dell piece of equipment. So now, again, it's just we're building more detailed information about the environment. And we can see, okay, yeah, there's Dell, right? There's our Schneider PLC. But again, it's also about what if we had another packet capture? And this is where those statistics, right, reports come in handy because what if there's more different IP addresses, right? And this is a packet capture, and that you'll find this. I think this is number two. If you look in the list of packet captures, right, where there's actually more than two or three, IP addresses, and your eyes kind of blur because you see like 100, 110, 101, right? Don't make it easy for you. But and then you can go in and you can see, is it, reading, not only reading things like coils and registers, but also, right, you can see that third and fourth packet, right, we're writing, right, we're making changes. Because again, it's an unauthenticated protocol. You're never asked for a username and password. And you can read data from memory of the PLC, but you can also override, or you can write to those sections or those data points in memory to then make changes to what's going on in the actual real world. And that's why, unencrypted and unauthenticated protocols like Modbus are dangerous, because they do allow somebody to connect to the asset, not only read what's going on in memory, but also make changes to the data in memory, which can be reflected in the real world. And that's where you start turning off pieces of equipment, or making pieces of equipment go too fast or too slow. So I did want to show, I just want to pull this up real quick, because if you want to dig into these more, let me see if I can find capture. um, Okay, yes. So here's the Ampex Cyber, what they call the ICS PCAP analysis challenge. Let me share this out real quick. So that way, again, I think they did a really good job. Special thanks to Patrick Miller and Dan Ritchie, who had put this together. And so you can see it at ampexcyber.com, and then ICS PCAP analysis challenge, right? Or just Google for I think I Googled for Ampex and packet capture, and it came up. So you can see that, again, they give you a couple of different scenarios. I really like how they took the time to put this together, right? And you can use Wireshark. Network Miner is another packet capture and analysis tool that's kind of like Wireshark, but very different as well, right? It kind of gives you more high level information. It's almost like a cheat sheet in a way. So, but it does some really cool things that Wireshark doesn't necessarily. So, like the cool thing is it like if you transfer a file, like let's say a picture file or a document, like a Word document, in that traffic, and it's not encrypted, that network miner will actually automatically pull that file out and save it, and then you can sit there and read it, which is really cool. And you can do things like that in Wireshark, but it's not automated, and it's kind of a pain. So, uh, so yeah, you can see DMP3, and they even mention, and this is Ampex, focus is on OT or ICS cybersecurity and power generation and transmission, right? So you can see, and that's the main protocol you see in these types of environments, like substations, right? So there's the DMP3 challenge, which is really cool. There's one for SIP, right? Which is, is usually associated with things with like Rockwell PLCs, and then of course Modbus. Oh, and I don't remember Zigbee being here, so I don't know if I completely missed that before or they added it. So that's actually pretty cool because I'll have to check that out because Zigbee is my favorite wireless protocol to say because it's just fun. So, but and Modbus. So probably if you wanted to start one of these, after this session, probably start with the Modbus one first. Again, if you're new to Modbus, I definitely, take 5, 10, 15, 30 minutes, right? Do some research on Modbus, how it operates, how it works. Same thing if you're going to dig into these others, right? Take, a half hour, maybe 15 minutes, to read up on how DNP3 works. So then when you're actually opening up these packet captures and tools like Wireshark, you'll have a much better understanding of what's actually happening, so what you're actually seeing. So yeah. But anyways, it's top of the hour. So I do appreciate everybody for coming and the time. One day I will remember to turn off the damn mute button before I start. So I actually did record an entire like 2 hour session one time for a YouTube video and was on mute the entire. You think I would learn, but apparently not. One day. So, but I do appreciate everybody's patience. I do appreciate everybody for being here. If you have questions, again, feel free to reach out to me on LinkedIn, or you can always drop a comment in the video if you're looking at YouTube. I do respond to all the YouTube comments, and I try to get back to everybody on LinkedIn. I just get a flood of LinkedIn messages every day, but I love when people reach out, and I will get back to you. It just might take a day or two. So, all right. Thanks again, everybody. Have a good one out there. And